What we're going to do here is learn some general guidelines about how many bonds a particular atom can have, and this is going to allow us to draw valid Lewis structures. So what we're going to do to figure this out is draw an electron dot symbol. And we do that with the aid of the periodic table. So the group number from the periodic table equals the number of valence electrons. So if we look at our excerpt of the periodic table here, we have the group numbers on top in Roman numerals. So we have group 1A, and then I've skipped, and then we go to 3A all the way up through 7A. So we can say the number of valence electrons for hydrogen would be 1, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7. And that would apply to any atoms in that group. So then, to draw our electron dot symbol, what you want to do is think about the atom being essentially in a box with 4 sides. And what you do is you put 1 electron on each side, and then once you've put an electron on each side, if you have more than 4, then you can start to pair electrons. So now if we draw the electron dot symbol for each of these atoms, hydrogen, we just put 1 electron. Boron, 1, 2, and 3. Carbon, 1, 2, 3, 4. Nitrogen, we have 5. So we do 1, 2, 3, 4. Now we've put an electron on each side, so our 5th has to be a pair. So there's 5. Oxygen will be 6. So there's 4, 5, and 6, and it doesn't matter which ones you make pairs. And then fluorine would be 7. There's 4, 5, 6, and 7. The way we use these electron dot symbols is we look at how many unpaired electrons there are, and that gives us the number of bonds. So hydrogen has 1 unpaired electron. Hydrogen likes to make 1 bond. Boron has 3 unpaired electrons. Boron likes to make 3 bonds. Carbon, 4 bonds. Nitrogen, now because we have a pair, okay, we don't count the pair, but we have 3 unpaired electrons, so nitrogen likes to make 3 bonds. Oxygen, 2 bonds. And fluorine, 1 bond. These numbers, you can obviously get to them by drawing the electron dot symbols, but these are numbers you just want to immediately know. So commit these to memory. That way, when you're drawing structures, you just immediately know nitrogen should have 3 bonds, or carbon should have 4 bonds. Since this is organic chemistry, let's focus in just a little more on carbon. Carbon forms 4 bonds. Now, on occasion, we'll have an unstable carbon that'll have less than 4 bonds. Never draw a carbon with more than 4 bonds because that would violate its octet. So just a few options we could have here. You could have a carbon with 4 single bonds. You could have a carbon with 2 single bonds and a double bond. You could have a carbon with 1 single bond and a triple bond, or a carbon with 2 double bonds. These are the only bonding patterns you're going to see in carbon.